This is actually our code that will go in and deals with earthquakes in Utah.
Yes, our Python code. And the problem is the USGS website, as we're showing here, has a database full of earthquakes that have occurred over all the time all the way back to 2001. We want to use the past 5 years of this data and make a PDF of slope times intensity hazard index.
Yeah, so we will show you how you do that. To be able to use the codes, you'll be provided with this folder called Bolster, and from that folder you will see it needs to be on the D drive and in a folder called Put Your Temp Files Here. And we have all this information that we need. And in this user required folder, you open it up, you go to the MDX base file for Shakin. It also provides you with a geodatabase that has other required folders, such as the slope that has already been created from a DEN. So you see now we have our MDX file open in ArcMap, and so once you have that,
MXD file.
It's an MXD file, yeah. Once you do that, you will just load in the script, which is right here. It's located in the code folder in Bolster. And from there, you just would press enter twice, and it would run the code. But we want to show you a little bit more of
what all the code is that we just loaded in.
So how that works, we'll go through it right here. As you can tell, there's a little bit of information up here. It tells you where it gathers the USGS information, the website that we showed you, and kind of goes through the basics of what's going on here, which we will cover as we run through this code. When we run this, we recommend that you put a code in, you gather a code from the USGS website called 7725, and that one won't run. It'll be the last one you put on that names file here. It'll be the last one, and you do that because there's a memory glitch that we found, and this is just an easy way to bypass it. 7725 is always the last one on this list, and it will never run. If you see it later on in the code, it's basically just trying to get past it because we're not going to use it. And to start off, we just import all the required modules. Using that, we'll be able to use the objects and classes from within them. And this next set of code opens up that names file that we showed you and reads it into a list. And by doing that, we can access it and run through it in some of our loops.
And this part, we're just setting up a PDF file where we're going to load and append all of our exported layouts. And it's going to be called the Utah Earthquake Atlas. And
yeah, so moving right along right here, we start a loop which calls names from that list earlier, and it loops through every code. And so here we start to download the data. We access the website, insert the code name, which gives us the URL correctly, and we open up the page and write it out to this file right here. And once that is done, we need to unzip all those files because they all come out in zip files. So we access it through this glob, and after that we run another loop through those globs and we unzip it. The reason why there's a try and accept here is because this zip file doesn't really work very well if it already exists. So to extract them all through the zip file, if they're already there, somehow you already ran the code, or you're just trying to rerun a couple parts, it'll already say it's already extracted, move along, it won't shut everything down. This next set of code right here allows you to put in a header file and write CSV files from all these XYZ grid files that you've saved from the zip files. And so the XYAVI header stands for longitude, latitude, acceleration, velocity, and intensity. And those are just the information that the USGS gives us. So we open up some file paths, and we open up your text from the XYZ grid file, and we read this first line and call it the original head. And after that, we open up a new file called your info file. It'll be in an info folder in files, code info.txt. And it writes that original head, just puts it in there as text, and it closes it. And this next part right here is we're going to reread the XYZ grid file, because the last time we didn't delimit it at all. It was just straight text, how it came off the file with all the information the USGS provided. Now we're going to delimit it by spaces, and because we have to reread the file, we just take that first line of text and tell it to go away. We don't need it. It's not impertinent to anything else anymore. We just put it away, and we rewrite that first line in a new CSV file as the XYAVI. That's your header, and it writes the rest of the information.
And then we can call those headers as we use these columns for functions in ArcMap.
So successful. You have all your data. It's in the CSV format. We move right along to changing it into shape files.
Yes, so as we get into this part of our code, this is where we have all of our CSV files now, and so we set a variable for where we're going to save everything to. We make sure that our 3D extension is checkmarked so that we can use all the 3D processes. This part just sets our environment, and then create a list of all the files inside my folder, which is just all the CSV files. And then we go through, and this try and accept is because of 7725. It keeps it from crashing the program, and everything works and it's happy. So we start with the first file in our files of this list directory up here. So starting with the first file, and we'll go through this really long loop it goes from creating the shape file all the way through creating the PDF at the end. So this goes through and finds all the CSV files, and it creates a shape file here with the correct coordinate system, which we just define it from the USGS website. This gets rid of the .csv at the end so that we just have a .shape file. If it's a .csv.shape, then ArcMap won't run it. Same thing for this down here. After we defined all of our files, it became a .dbf file, and so we had to get rid of that in order to make code the F file, because as we downloaded all of our files, we wanted to run through that one file instead of what was in our code and names. This actually creates feature layers in ArcMap from our shape files, and then from those point feature layers we interpolated with this ArcMap function, interpolated a raster from those points. We did discover that we needed the original cell size in order to make the raster give us accurate values. And then after we recreated our raster, we were able to multiply our created intensity raster with our slope raster to get an index.
Right here again, 7725, it's a bad number. We skim right past over it. And we're taking our code, we make some new inputs, and we make a new mapping document current and set that as MXD. We need to create an actual raster layer for processing, so that's what happens in these two lines of code. As the next step, we refresh our table of contents interactive view, and then we upload a symbol layer which is inside the user required file, and that will allow all of it'll have our base map, it'll have all the text files and layouts that help us to make our PDF. And so we make sure that we use that custom symbology right here and set up a new variable that accesses that layer that we created earlier.
It's just renaming that layer.
Actually, it just renames the layer and allows us to use it down here in this little code. Refresh everything all up, get our extents to the extent of the earthquake boundary, and in this loop we just make sure that we're showing our renamed layers, the layers that we're concerned with right now, because eventually you're going to have a whole lot of layers in ArcMap that you're not going to want. So just what we're working with, and this next bit of code will input all of our information from here to here. We'll input all of our information into our map layout about the earthquake. So we open up our info files about all from each code, and we turn into a list. Those lists populate this information: our title, our magnitude, location, occurrence. This one will say magnitude, 3.9, or the occurrence, when it happened, date, time, year. And so all that is put into some predefined text elements in our layout view. You can see them right here. They already have some information in them, but everything will get uploaded into that. And so once it's uploaded, we refresh it all and get ready to turn into a PDF.
Okay, so we turn everything into a PDF just by creating a file for each PDF, and then using the arcpy.mapping export to PDF tool, we export that layout that it's in the loop for to a PDF. That PDF will be appended to the end of our master PDF. So after that layout is exported and appended, we remove all the layers that we created so that ArcMap doesn't get bogged down. Then the PDF is finished, and this will just count each PDF as it's running through, and we'll know how many earthquake codes that we've gone through. And then the PDF will save and close, except for the last one, which is 7725. So then it'll just accept out of that, and that code will fail, and we just accept that and move on. And then the PDF will really close, and you'll have all of your files in that folder looking beautiful.
So for the last 5 years, we came up with this PDF right here. There are 57 earthquakes that are involved in the last 5 years, and it goes through every single one. You see we have this earthquake in Utah from this boundary, right near Hurricane in St. George between Cedar City. This is its hazard index. The magnitude of the earthquake was 4.1. Happened on January 4th, 2010, and that's the event code from the USGS. And all these files are similar to that. Just you go through and you can see the areas of high risk, and you correlate it to this index down here.
Yep, and now we'd like to show you a little bit of how our code runs. So we'll put it into ArcMap and hit enter.
Our PDF is finished. 7725 dies, which is good.
It has created our PDF.
Created our PDF for our event that was running.
2715.
2715, right there. Live demo. We'd like to thank you for spending your time with us today.
Yep, thanks for listening.
And if you have any questions, please forward them to JC Smith.
Oh, thanks. I'll try to get back to you as soon as I can. Or forward them on to Stephen.